All right, we are live. So welcome everyone that's in the room already. I'll give you a few minutes to get settled and grab some note paper and let other people make their way in. Just give it a couple minutes here. All right, so let me know if you can't hear me. Last time I was on, I had some interesting technical difficulties, but hopefully we've taken care of those. My name is Nikita. I work with Kevin and the SwiftKick team. So usually you get Kevin as your gracious host for these events, but he had a scheduling conflict, so I've been thrust into the limelight. And so a bit about SwiftKick, if you're new to our webinar series. This is our latest. It's with Joel Cochran. It's Intro to Azure Data Lake. See if I can get these slides to come up. All right, SwiftKick is a software training and consulting company in Virginia. The mission with SwiftKick is to help software professionals everywhere level up their skills through in-person training and online sessions such as these. We're all over social media, so stop by and say hi. We're on Twitter, Facebook, LinkedIn. While you're waiting to dive in today, feel free to go tell your friends on social media what you're doing and see if you can draw them here. We're also on YouTube now. So all of our webinars eventually make their way to our YouTube channel, and you can watch them anytime. So we have a few more webinars in the near future. Greg Norman will be joining us December 6th about Google Assistant, more specifically creating conversational interfaces with Google Assistant. So that should be quite interesting. And then we have Linda Nichols. She hasn't decided what she is going to be presenting yet, but I'm sure it'll be fascinating. Emily Freeman is our first booking for January 2018, and she's still holding us in suspense on her topic. And then in February, we have Josh Carlisle with Be More Productive Than Ever with Azure Functions. And today we welcome Joel Cochran. He will be talking about Azure Data Lake. And I mean, rather than me try to explain everything, I'm sure he'll dive right in and give us his expert views. He's the Chief Technology Officer for Causeway Solutions with an impressive history in tech. So I will hand over the reins to him and fade back into the background.
Thank you, Nikita, and welcome everyone. Thanks for joining. And yeah, let's just dive right in. Let me get going here. And I trust that's coming through all right. Okay. So we're going to talk today about Azure Data Lake, and this is by no means exhaustive. Data Lake is a large topic inside of several other large topics. But what I want you to take away today is a feeling that you can do this kind of stuff yourself, and that Azure supplies the tools and the technologies that you need to be successful when processing big data workloads. So we're going to start by talking a little bit about what big data means. So big data is more than just size, although obviously size of files and the amount of files, as we see in our first two bullets here, are really important. But big data is really, it's a little bit of a misnomer. It's really data that is difficult to work with, difficult to acquire, expensive to analyze, and frequently updates. So big data in a lot of those scenarios, and the kind of scenarios that we're going to talk about today, is typically represented in a series of flat files or just text files. Because the reality is that it becomes really difficult to manage super large workloads, especially workloads with unknown schemas or changing schemas. It's difficult to do those kinds of things in typical traditional RDBMS. So big data systems have evolved to handle these kinds of text-based, schema agnostic, or what we call late schema, we'll talk about that later, scenarios. And so that's sort of just a super high level view of what it means to be big data. At Causeway, our big data comes in several flavors, and the biggest problems that we have revolve around the fact that we are dealing with nationwide sets of data. We deal with data from public records. We deal with voter file information from several different sources. We deal with consumer files from several different sources. There are no central repositories of all the kinds of information that we need to work with and aggregate. There's no master schema that says, defines even simple things such as what is a person, what is an address, what is a phone number. All of these coming from disparate sources have different ways of viewing those kinds of bits of data. And so we have specific problems around trying to match rows together, around trying to standardize and perform analysis, again, over these, what are essentially text files, large collections of text files that we try to bring together into a unified system. So currently we have a little over 300 terabytes that we deal with, and we're growing constantly. Our data is updated fairly frequently, but also fairly irregularly. So sometimes it'll come in bi-weekly, sometimes it'll be quarterly, sometimes it might only be annually. Excuse me. I apologize for all of us. Unfortunately, I do have a bit of a cold, and if I have to cough, I will do that, hopefully without doing so in your ear. Some of the specific problems that occur that you have to deal with or solve in this sort of area are ingestion. It becomes a challenge to ingest large text files or many text files. And if it's many large text files, then you're just making the problem that much larger. Processing and analytics also over such a background, such a data store is a specifically problematic. And then I mentioned matching earlier as well, and that's the demo when we get around to looking at some code will be involved around matching. So generally speaking, to solve these kinds of problems, what has cropped up over the last decade or so are a series of or a group of technologies that come together to be known as massively parallel processing, or MPP. And generally speaking, the way that an MPP system works is that you have a head node. It could be a VM, it could be in a container, it could be a standalone server, but it's a server whose job is to manage and distribute a workload into parallel child nodes or worker nodes. So you imagine that a request will come in and you want to write a particular query over, say, 200 text files, CSV files. Then the head node's job is to analyze the query request and to figure out where to send chunks of work. and it will send those chunks of work off to the worker nodes. And then those worker nodes will each perform the tasks that they've been handed off to by the head node, and they'll return just their individual results with no connection to the other worker nodes, and return those individual results back to the head node. And then the head node's final job is to aggregate those results and report them back. The only way to make something like this work is to have storage be separate from compute. So you end up with a system of storage that is different, that is not specifically tied to necessarily the compute system. So that presents some interesting challenges as well. And again, the worker nodes will be told, here is the storage that you are to process. And the head node is managing that entire process. So that's MPP in a nutshell. And and here's just a little diagram that kind of demonstrates how that works. And so if we work left to right, and in this case, our storage is Azure Blob Storage, or Azure Storage Blob. Azure Storage is one of the older services in Azure, and it's kind of connected to everything. So everything knows how to work with storage. It's also the least expensive. It's a highly commoditized storage system, and it can hold virtually any kind of file, blob that you put in it. But it does have some, Azure Blob Storage in particular does have some limitations around size, and we'll talk about that a little bit going forward. But so this parallel processing is what allows us to write queries and to write analytics routines over these large data sets on the back end, and retrieve and get some kind of performance out of that request. If you left it to a single server, or let's say that you were building your own farm and you had 4 worker nodes, that's great. You have 4 servers, but maybe it takes 72 hours to run a query. Whereas it would be really nice if I could just have 200 servers doing that work for me, but I only want them to hang around just long enough to do the job. And so that's the kind of scenario that we're going to see develop. So in Azure specifically, we really have 3 flavors of MPP. Azure SQL Data Warehouse. This is a very traditional SQL data warehouse solution in the cloud. It's SQL Server based. The commands are all written in T-SQL. It forms exactly that same kind of structure that we talked about before. There's a head node, and then there are a bunch of worker nodes, and each of those nodes in SQL Data Warehouse is in fact a SQL Server. So if you create a data warehouse and you want 4 worker nodes, then you've created 5 SQL servers, 1 SQL Server head node and 4 child nodes. One of the drawbacks to data warehouse is that it is schema oriented, and so the schemas must exist in order to load data, etc. And then in order to access the underlying data, even though compute and storage are separate from one another, they're tied together from a processing perspective. And so in order to access the data that's in a data warehouse, it must be turned on. And so you are paying for a data warehouse to be up whenever you want access to the underlying data, as well as whenever you want it to be actually executing jobs. It is rather expensive, but if you were dealing in petabyte scale scenarios that require fully relational databases, it's extremely functional and very performant. HD Insight is Azure's managed Hadoop clusters. So you can go to the Azure Portal, and if you know Hadoop and you want to spin up, a VM with, say, 2 head nodes and 6 worker nodes, you have that flexibility. You can create Windows servers, VMs, or Linux VMs, and all of the processing works on Hive and Pig. There's a lot more we could say about Hadoop and HD Insight, but they're kind of out of the scope of today's conversation. Excuse me. And interestingly enough, HD Insight now actually falls under the umbrella of Azure Data Lake. So HD Insight and Data Lake or Hadoop and Data Lake rather, are both Yarn implementations. Again, outside the scope of today's conversation, but they are related in concept and they're related in some of their underlying structure. So HD Insight is technically part of the Azure Data Lake family. And I point that out because when you get to the point that you're getting into the tooling and stuff, when you go to work with Data Lake, you'll see some HD Insight assets, and so I just wanted you to be aware of why that may be the case. Hive and Pig are the languages that HD Insight uses. So if you are coming out of a C# or a T-SQL background, you'll have a little bit of a learning curve there, especially with Pig. But Azure Data Lake is really what we want to obviously talk about today, and it is also an MPP. Its storage and compute are in separate systems. All of the job, the work is done via a new language called U-SQL, and we'll talk about that here going forward. And then Data Lake is job oriented. So I mentioned with Data Warehouse that the data warehouse must be active and running, which means that, from a costing perspective, that you're paying for it. HD Insight is largely the same way. There are some ways to do HD Insight on demand, mostly through Azure Data Factory, which we'll also touch on momentarily here in a moment. But HD Insight effectively needs to be up and running. Azure Data Lake, the two systems are entirely separate from one another, and Data Lake is an HDFS compliant storage system. Like I said, they share some of the same underpinning that HD Insight has, but the data and the compute are completely separate from one another. And the compute only runs when a job is running, and you pay literally by the second for the number of job units. Well, we won't call them servers, but those are the units that are used to determine the power or the amount of parallelism. It's called an analysis unit. So Data Lake storage is sort of like it's actually kind of it's a binary system. There are two different ways to think about Data Lake storage. There is regular blob storage in Data Lake. And the difference between Azure Data Lake storage for blobs and the difference between Azure blob storage is that blob storage, traditional blob storage, has some limitations. It has a limitation on the number of blobs that you can have in a particular account, and it has a limit on the physical size of an individual blob. Data Lake storage blobs are completely unbounded. So you can have as many as you need to be, and an individual blob can theoretically be of any size. So if you're dealing in super, super large files where you have petabyte size text files, then you could do that in Data Lake storage, but you could not do that directly in Azure blob storage. So at Data Lake, when we talk about analytics here in just a moment, it has the option to work with either Azure blob storage or Azure Data Lake storage. And so you can still process those flat files directly, regardless of whether they're in blob storage or Data Lake storage. And you can do that directly in U-SQL. And we'll see an example of that when we get to the code. But Data Lake storage also has a mechanism for creating a database. So you can create tables and views and store them in your Data Lake. So the data is already extracted from the files, and it's already present in tables. So we have now applied a schema to a file, but we've done it after the fact. So we ingest it early on, and then we can, again, optionally create a table out of it. And the benefits of creating the table mean that every time that I want to process it, so we have files that we process that data over and over and over again. I don't want to have to open the file and extract the data and apply the schema at runtime over and over and over again. And so a table allows me to actually do that job one time, and then only when the data changes do I need to rerun it to update the table. So it's I call it a quasi-relational data store. as you'll see in our example later, it does allow you to do things that you typically do in SQL, like joins. You can create indexes, and you can do all of those things. But you're still, it's still running within the data lake storage. We mentioned earlier that ingestion is a problem. And so data lake storage has several different ways to do ingestion. And the example that we're going to look at is actually to use data lake analytics to do that ingestion. But if you just want to physically move blobs around, you can use a tool called ADL copy, and that will allow you to move a blob from blob storage into data lake storage. It will also allow you to move data from one data lake to another data lake. A more common scenario is to use Azure Data Factory. It's a little bit out of the scope of today's conversation, but Data Factory is an orchestration tool that allows you to move data around and possibly optionally apply some transforms. It's not like SSIS because it doesn't rely on a SQL Server, although it does know how to talk to SQL Server and SQL Data Warehouse and Data Lake and HD Insight and a few others. Of course, you can write custom code as well in C#.NET to do effectively whatever you want to do. But Data Factory has a copy feature, a copy data feature, where you can pull data out of one destination and write it to a source. And you can really do that with effectively no code. So you can do that through the portal. And so that's also a very easy way to get data into your data lake. And then finally, SSIS recently released support for sources and targets. So you can use an Azure Data Lake storage account as a source or a target. So if you are working in SSIS and SQL Server, you can use those tools if you're comfortable with SSIS to write data into and retrieve data out of your data lake. Data Lake Analytics is the compute aspect of Data Lake. So as I mentioned before, there are a couple different ways that it can process data. So you're not going to connect your data lake, at least in today's tech, you're not going to connect your data lake analytics job, say, directly to a SQL Server. You're, again, understanding that these systems are largely text file based. You're going to connect it to a blob in, say, Azure Blob Storage or a blob in Azure Data Lake Storage, or you're going to access one of those data lake tables or views that we mentioned earlier. I have a couple side notes here that blob storage and data lake blobs are both extraction operations. So that's the scenario I was mentioning where I don't want to necessarily have to open the file and process the file every time that I want to use the data, because that can be, it can take a little time to do sometimes. If I have the data in data tables, then I have direct access to that data. That work's already been done. And most of the work that we do internally for our heavy lifting is done through tables. Data Lake Analytics uses a fairly new language called U-SQL. And U-SQL is the coolest thing, I think, in the Data Lake family. I'm crossing my fingers that someday we'll be able to do it against SQL servers as well. But for right now, U-SQL is limited to Data Lake Analytics jobs. It's based on T-SQL, and we're going to spend most of our time in code looking at U-SQL stuff. So don't worry, you're going to see some of this. But just so you know, it's based on T-SQL. But it's a version of T-SQL that knows how to talk C#.NET. And so you can incorporate C# directly into your U-SQL code, directly into your queries, and that's called inline. Also a very traditional Microsoft-y way of doing things is that you have a code behind file. So there's a file that is our U-SQL code, our T-SQL-like code, and then there's a file that's simply C# that it can be leveraged locally by the T-SQL. And so that's a code behind. And then we can also create a project that is a U-SQL DLL, and we can register that DLL with our data lake. And that allows us then to take this DLL and use it across multiple data lakes, because I can register it however many times that I'd like. So that allows us a lot of functionality and reuse through via registered DLLs. And so we'll have some examples of all three of these things here going forward. And then finally, data lake analytics, as I mentioned before, it's all job oriented. So you determine your parallelism rather than determining it at the time of creating VMs. You determine it at the time of executing the job. So we're going to get to the point that we're ready to submit a U-SQL job. And at that time that I submit it, I tell Data Lake Analytics, here's how much parallelism I want you to take advantage of. And so that is extremely flexible. It's better than the other alternatives, because again, I'm pushing that decision off as far as we can do at the moment. Okay, so before we get started in Visual Studio, let's jump over to the Azure Portal and allow me to show you just a couple of brief things. So this is the Azure Portal, and I've selected a data lake storage account, and I just want you to see that you get some visualization in the portal. You can see that this data lake has about 3 terabytes in it. I have some reports on when were my last read-write requests, ingress and egress into and out of this data lake storage account. I didn't mention access control. One of the nice things about Data Lake is that it's connected to your Azure Active Directory, and so you control all the access to your various data lakes through your Active Directory. And then I can also do some mild Data Explorer work here in the portal itself. And then a lot of the U-SQL jobs will actually use the data lake storage account for temporary files and folders, and so most of what you're seeing here is actually generated by Data Lake itself, by the analytics jobs. And then while we're here in the portal, I also have one of our Data Lake Analytics accounts open, and so this is Lake Causeway. And one of the nice things here is that it will show you recent activity, as well as if we look and we'll see, that we have some successful jobs, we have some failure jobs. And so obviously the more purple you see is when we're developing solutions and testing and experimenting. And then this will give you an idea of what your cost is. So our current estimated cost on this particular data lake is $250, give or take, and we've used 124 hours of compute time. And again, you actually pay down to, it's either the minute or the second, I forget, but you pay only for the compute time that you actually use when you're processing U-SQL scripts. So one interesting thing, and I've never actually done it because we're going to use Visual Studio, but if I really wanted to, I can run a job, I can write the U-SQL query, and I can run a job right here in the portal. So if I knew the U-SQL code that I wanted to write, I could just simply write it in this box. And then here I can kick up the units that I want to. So I'll slide this all the way up to the top, which is currently 250. And it's telling me, hey, that's going to cost about $8.33 a minute. So if you think of it in terms of VMs, which I know is not accurate or fair, but we'll think of it that way. If I'm spinning up 250 VMs, odds are, I'm going to finish this job fairly quickly. I'm not going to get into all the specifics of job graphing because there's some kind of more advanced topics that we could get into there. But pretending that it could take advantage of all 250 of these units, then it's going to operate. It's going to come. It's going to perform this job really fast. And rather than if I try to kind of do this on the cheap, where I'm doing say maybe 5 units, if I grab this guy and go back down to, well, we'll just do 7. Okay, that's 23 cents a minute. That's not an insignificant difference between 23 cents and $8.33 a minute. But if the difference is 500 hours here and 1 hour there, right? And somewhere there's a mathematical sweet spot that says, you know, this many units has enough of a benefit to pay a little bit extra cost per minute, but at a certain point there's a law of diminishing returns, and so you just sort of need to experiment with that. And if anyone's interested, we actually have some research that we did at Causeway posted on our website that I can share the link to that, where you can go and you see some charts that will show you kind of, you know, this many minutes and this many pennies or dollars or what have you. Again, this is getting off topic just a little bit, but it does let you perform some of these operations rather from directly within the portal. That being said, you know, most of us, I'm sure, are developers, and you know, we're much happier in an integrated development environment. So naturally, we want to use something like Visual Studio instead. So let me hop back over to our slideshow for just a moment. So the first thing you'll need to do in Visual Studio is you'll want to install, and this is in 2017. I'm not sure what the 2015 status of this is, or the reason I mentioned that is this used to be named something else. I believe it was Azure Data Lake Tools, and recently it became Azure Data Lake and Stream Analytics Tools. So that's the extension that you'll want to install in Visual Studio. And then we're going to look very briefly at some U-SQL code, and we're going to see some U-SQL scripts. We're going to see some code behind, and we're going to see a DLL and how to deploy that. And then naturally, this integrates with your source control. So that's something that was, that's very important to us. We run everything through VSTS, and we want to make sure that, we put a lot of time and effort into these analytics jobs that we are it's easy to retain and update and manage through source control. And so developing in Visual Studio allows you to do all of those things. And then finally, that job execution that we were kind of toying with in the portal, we can actually do directly from Visual Studio. And internally, all of our U-SQL jobs are executed directly from Visual Studio. And with that, I think we're ready to actually look at some code. So I'm in Visual Studio. And let me pump up the size of that code just a little bit so make sure everybody can see it okay. And what you're going to see in U-SQL, as I've kind of alluded to, is a very T-SQL-like language. So if you're comfortable with writing queries in SSMS, you're going to be pretty comfortable fairly quickly in U-SQL. Here we have a used database. And we'll discuss this here. We'll discuss that here in a moment as well. I'm in a particular database because I can have multiple databases. I'm dropping a table if it does not exist, if it exists, and I'm creating a table if it does not exist. The one thing that I do want to point out here is that if you start looking at the field types, these are .NET field types. So here is a nullable int. And here's a GUID, and most of them are strings. Most of the work that we do is with strings, but you do see kind of a collection of those. And you'll see right away, I've got a lot of columns here in this table. So I am creating a schema, and I'm going to store that schema. And then I have some more advanced items here, and you'll see this in SQL Data Warehouse as well, is the ability to determine how data is distributed in the storage. So we're creating a clustered index, and we're distributing by a round-robin methodology. And that will simply create the table. So if I stop right there, and here on the left we have Cloud Explorer, and I hope that's coming through. Let's see. Can I do... I'll try this out for you. Okay, I don't know if that's working or not. I think I have to stop that. Okay. So if I'm in Cloud Explorer and I'm looking at this particular subscription, and I have Data Lake Analytics. And when I expand this, this is the data lake that we're looking at. And I'll expand that one more time. It's not usually this slow, so these are the demo gods doing their thing. Okay, while that's loading, let's go back. We'll just spend a little more time looking at the code. I was just going to show you. Okay, here we go. Great. So in databases, this is the superior database that we're looking at. And then here are tables. So you can get a lot of the information out of here. And we'll look at a couple other things in here as we go forward. As you'll see, you can also create stored procedures, and you can create table functions as well as views. So again, if you're familiar with SQL Server, there are a lot of things here that are going to feel comfortable to you. And this table that we're creating is the national voter file. And if I expand that, since this code was already ran, obviously we use this is all real. Everything I'm showing you today is real code. We don't do demoware. And if I look at the columns here, this should match all of those columns that we saw in that list. So quite a few more. Great. Okay. So I just wanted to see you can use the Cloud Explorer to kind of investigate a little bit. And there's our N32 nullable. So let's minimize this guy for just a second. And you cannot do a select into, or I'm sorry, you cannot do a create table with a select into. Hope I'm not making anyone dizzy here. So now that the table exists, I'm doing an insert into that table, and I'm doing a selection. And so these columns, and here's a little bit of work here. So here's some inline C#. So if this value is 0, then throw in the area code. Right? Else null. Now this is not the name going right. That's going because this is a select into. This is the name I'm pulling out of. So I'm creating several different columns here, a whole collection of columns, all based on this is wireless. And if you can think to your T-SQL days, what this would have looked like in a case statement, this is rather cleaner. This is pretty nice stuff. Being able to do this, and so we get down to the end. And now where am I getting the data from? I'm getting it from an extraction. So I'm extracting these columns, and I'm naming these columns on the way in. So these are the simply columns coming out of a CSV file. And would you believe this is one of our smaller files? So it's kind of a pain, but where am I getting that data from? And so where I'm getting it from, I'm doing an extraction. So that tells us I'm doing one of the blob storage mechanisms. WASB is Windows Azure Storage Blob. So I'm reading this out of a traditional blob storage account. There's a container called RNC voter file in an account called Causeway Data Lake Store. And this is a wildcard that says, aggregate all of the files, all the .csv files that are in that container. So there might be 5 in here, there might be 5,000. I'm going to take all of those and I'm going to merge them together, and Data Lake's going to treat them like a single file. And I'm going to extract, and even though this is a CSV file, we have an odd situation where it's actually pictolimited. And I'm skipping the first row. So this is extractors.txt is a C# method that's baked into, there are several default extractors and several default outputters that are baked into Data Lake. So this comes out of that Data Lake extension, the SDK. And then I'm calling that the voter file. So the end of all this is to actually populate that table that we created up here at the beginning. So what I've done is, again, I've created a table in my Data Lake storage account. and I have extracted the text file from a collection of CSV files, and I've written that data into the table that I created. And again, so you can see why I don't want to have to do this extraction process over and over and over every time that I want to do some work against this this collection of CSV files. So it's very nice to be able to simply do it once. Now, if we look at another script here, there's a couple things I want you to see. Yes, we have some red squigglies, and I will explain that in a moment. But what I'm doing here is I'm actually going to now process. We talked about matching a little bit earlier. I've got one table here called info group, and actually called info group. And I've got that voter file that you just saw us create. And what I want to do is I want to try and perform some matching against these two. So it's sort of like a union, but not exactly, because there's some statistics and mathematics and algorithms that have to be run to determine likelihood of match and things of that nature. So the first thing I'm doing is out of my table. So this is another table that I've already created. And I know it's a table because there's no extract statement. I don't have to extract it because that work's already been done. So I'm just accessing this table kind of like I would in T-SQL. I've given it a where clause. So in this case, I just want to limit it to all of the S's in state of Louisiana zip code 70003. So I'm going to take that small little subset of people, and I'm going to do a select statement. And that table has maybe 1,000 columns in it. And so I just want to work with these columns. And so I'm going to select these out. And this guy right here, superior U-SQL.helpers.buildInfoGroupDate, is actually a method. And that method is in code behind. So if I look over on the right, and we are in matching test 1, here's matching test 1, and underneath that is matching test1.usql.cs. So that's my code behind file. So if I open this up, I've got several different methods in here, and here is build info group date. So this is the method that we're calling, and so I'm doing some C# work, and I'm just going to return a string. So I'm passing it a couple of other strings. I'm doing some analysis. I'm setting some defaults. I'm standardizing some values, and then I'm going to return a value. And that return is right in my select statement. So that is super, super nice to be able to do this, to solve kind of those complex problems. Because if you could imagine trying to write something like this in T-SQL, it's going to get very complicated and very ugly. I'm probably going to have to call it to a stored procedure or do something like that. Whereas here, I can simply call a C# method. So I'm calling my C# method. One of the caveats that I will share with you is that if you notice everything in here has to be static. So you cannot instantiate objects. It's one of the limitations of the C# part of U-SQL. And then second, I'm sorry, and so to follow, so all of these methods are static. So they have to be static. The class doesn't have to be static, but the methods do. And then in order to call it, I have to fully qualify it. So superior U-SQL is our namespace, helpers is our class, and build info group date is our method. And if we go back and look at our code, we'll see that it's fully qualified to call that. Again, just a couple minor things you have to be aware of. Here's another interesting one. It is case sensitive. U-SQL is case sensitive. And beyond that, commands must be in all uppercase. And the corollary to that we recently ran into is that only commands may be uppercase. So we tried to create a field that was, something. If I just tried to say that's zip, that's going to fail when I try to run it because it's going to say that it doesn't recognize zip as a command. So just another little gotcha there that we'll share from our experience. Okay, so I've got, this is the first query that I'm going to run. And I'm taking the results of that query and dumping it into, not really dumping it into, I'm creating what's effectively a temporary table, for lack of a better way of thinking of it, a temporary table called info group. And then I'm doing the same thing here on voter file. And notice that I'm calling another. So there's another code behind method call. It's a different one. Here's some more C# work, actually, because I'm doing some trim work and then concatenation, and that's using C#. Here's another example of calling a code behind. And I'm doing all that in the select statement. In this case, I have the same where clause. That makes sense because I'm trying to match these two things together. And I'm dumping that into a temporary table called voter file. They're really just variables, but think of it as a table. Okay. And now that I've extracted, I shouldn't use that word because that actually means something. Now that I have collected the data that I want to use for my matching work, I want to combine them. And so I'm going to do a join. So here is combine, another temporary table, and it has all of the columns from the first two temporary tables that we created, the first two select statements. And then I'm also I've got a set of scoring algorithms here. And these, I'll show these in just a minute, but these are actually coming from a registered DLL. So these scoring routines are in another solution. They're even in another source control repository, and they are published or registered. That DLL is registered here with the superior U-SQL. So if I go back to our Cloud Explorer and scroll up to assemblies, and hopefully it won't take too long. Here are the assemblies, and these are the external DLLs, and so we'll get into those in just a moment, but these are registered. And here at the top, you'll see where I'm referencing those assemblies. Now we're getting some red squigglies here because these 4 boxes at the top reference the data lake. And I'm actually telling this right now, and I'm not telling it, it's by default, I haven't changed it yet, to look at local. So you can set up a data lake locally to do development work. Obviously, all the rules around data lake change when you try to do it locally, but you can totally do that. And there is a master database like there is in SQL Server. So what I would really need to do if I was ready to compile this is change this to the correct data lake analytics account and the correct database. And then if I were to build this, which is, believe it or not, a U-SQL job, if I were to build this, it would take about 12 or 13 seconds, and then those red squigglies would go away. But for now, just trust me on that, and we'll go back down here because I want to finish off what we were talking about joining. So, before we get into the DLLs, I am now joining the 2 temporary tables that we created above. And I'm joining it on zip code and standardized last name, which is one of the generated fields that we used. And that will create another temporary table. And now I want to output that data. So I actually have a couple of different data sets that I want to look at. So I have some questionable matches. So combine is the temporary table we just created by joining the other 2 tables together. And remember that join actually calls out and does the scoring work. So now my temporary table contains the actual data that I want to look at, the scored data. So the analytics, if you will, has been performed, and now I'm ready to start looking at that. So I'm going to take that result set, which could be quite large, and I'm going to say I want to select all the fields from that temporary table where the match score is in this questionable range. So I'm thinking anything under 0.7 is no good. Anything over 0.9 is really good, and I'm calling that a high match because I'm doing that down here as well, which demonstrates that I can do multiple outputs over a temporary table. So I have this temporary table combined that I've created, and the first thing I'm going to do is get the subset of this subset A, the questionable subset, and I'm going to output it, and I'm going to output it to WASB, Windows Azure Storage Blob. So I'm going to send this to a storage account, or rather a container in a storage account, and I'm going to give it this name. So that data is going to be written out as a CSV file because I'm using, again, one of the baked-in outputters is outputters.csv. And I want it to output a header row and turn off quoting. So this statement here will take the results of that temporary table that we created and create a CSV file for us in Azure Blob Storage. And then we do the same thing again down here, which is going to a different file name and has obviously has a different match score, right? So we have two CSV files that are being output by this one job. So first, this will take a couple minutes to run, but I do want you to get a chance to see the job graph. So I'm going to go ahead and kick this off, and then we'll switch over and look at the DLL and how you would go about creating and registering a DLL to use. So I'm going to start by I'm going to build this code. So I just did a Control-Shift-B, which is what I always use to build C#, and I'm doing the same thing here for U-SQL. And that'll take it, like I said, about 12 or 13 seconds. Except since we're doing demo, it'll take longer. Okay, there we go. Great. 13.54 seconds. But it compiled. Super. So we'll turn that off. And as promised, the little red squigglies went away. And now I'm ready to submit. Now, if I just hit submit, it's going to use the default settings. And the default settings are pretty low. It's about 5 UAs, about 5 parallel jobs. So I'm going to open this up and say advanced. And the advanced window, when it pops up, will allow me to change the parallelism. So I'm going, and I could name this a different name, and I could even run this against a different account if I really wanted to. But I'm not going to use the slider. I'm just going to bump this up to 100. So we're going to run 100 parallel units on this work. And I can tell you if we ran this with 5, even with a small set that we're running, I'm trying to remember, it might take 30 minutes, or it might take, close to an hour. So I don't remember, something of that nature. But if I bump it up to 5, it'll take about 3 minutes. So I'm going to say submit. And we'll give it a second to start so you can see the experience. And it's in the process now of preparing the job in Azure. And once it'll go through preparing and queued pretty fast and start executing, and it'll develop a job graph. And then you can start to see how ADLA is going to manage the job itself. And so it's doing that head node work that we talked about at the very beginning of the presentation, where it's trying to figure out how to best parallelize this workload. And so give it a couple more seconds. If it doesn't happen, we'll just come back to it. Okay, I'm too impatient for this. So I'm just going to let this guy run. And in the meantime, we will hop over to a different solution. So let me run this up here a little bit. Hopefully everyone can see that okay. So I'm actually in a different project and a different solution, different instance of Visual Studio. And let's pretend for a second that I wanted to start from scratch, just so you can see how to do this. And first of all, I did mention earlier, but I just want to reiterate, under Tools and Extensions, you do have to have Azure Data Lake and Stream Analytics installed. Okay, so one of the things that installs, if I right-click on my solution and say Add New Project, one of the things that installs are the Data Lake templates. So here in my new project window, I have Azure Data Lake, and lo and behold, as I promised earlier, there's some Hive, there's some Pig, Storm and HBase, these are all supported items in HD Insight, but they fall under the Azure Data Lake moniker. The two that we really care about are down here at the bottom. A U-SQL project is that's what the first one that we looked at that actually runs the U-SQL scripts, and then a class library for U-SQL. So in this case, when I'm creating a class library, I'm going to select this template, and what that does for us, that's how this was created. And the rest of this, by the way, is just C# code. So there's really nothing in here that's totally specific to Data Lake. This is C#. The exception is when I right-click on the project, and this all builds and everything. And by the way, match score here, I know I'm jumping around a little bit. I apologize. Oh, still no job graph. That's unfortunate. If we come all the way down here to this set of code, if I just look at the last one, causeway.matchers.library.scoring.scorer.matchscore. Again, as you can tell, I'm a big fan of nested namespaces and all that sort of. That's a great organizational technique, but you have to remember in U-SQL that you need to fully qualify everything. So you end up, unfortunately, with a little bit of this once in a while. But that guy right there is this method. So here's my namespace, there's my class, and there's my method name. And again, like everything else, it has to be static. And so this came from, or this rather came from this DLL. So and this code does some pretty complex statistics and analytics, as you can see, and it returns a matching value. So if I go now to my project, I've compiled all this, I'm happy with it, it works. Of course, I have my unit tests to tell me that that's all true. I'm going to right-click on the project, and I have this register assembly option. And because it knows that it's a U-SQL DLL, it knows to connect to my data lake, and it knows how to register this assembly in the data lake. So I right-clicked on that, which means we'll have to give it just a moment here to give us the register assembly dialog. And here we are, and it's now looking for me. The very first time that this runs, it takes a little while. And what it's doing is it's loading the list of my data lake accounts. And so if and when that finishes, we'll be able to select the correct data lake. And while we're waiting for that to happen, notice that I'm not going to do anything with credentials here because I'm logged in with my Azure Active Directory account, and that Azure Active Directory account is registered with the, is connected, of course, to my data lake. So okay, great. So and it knows that we're all set and ready. So those options went away because it knew how to connect me, and that's also how it knew that this is my data lake. And that inside my data lake, it's now loading the databases. Should take just a second. And there's my superior database. And then everything else is just default. You can change these options, but I've never needed to. The exception here is I always use replace assembly, because I'm obviously publishing something that I've published many times in the past. And if I submit this, I'm going to get this message because of the size of the deployment exceeds 15 kilobytes. And this is where I was saying a lot of those directories or folders that we saw in the Data Lake storage account were generated by Data Lake. That's this is one of the processes that does that. So it's going to create one of these assembly cache folders, and all it's doing is shuffling files around. So I'm going to say yes here. And parallelism in this case is just one. Because all I'm doing is registering a DLL. So I'm not even sure what the value of this parallelism would be if it would have to be a really significant publish to do anything more than one job. But this registration is actually also a U-SQL job, like our compile was, and like the other job that we're running right now. And so this should be submitted, and it'll take it a few moments and come up with, if we look in the background, we'll see it's actually uploading the files now. And that progress will report here. It's usually much faster than this, but it still takes a few minutes to actually publish and register a new assembly. But it's this process that allowed it to show up when we looked at Cloud Explorer in this assembly list. So this assembly value here is a result of going through that register assembly process, which is also, again, what allows us to reference the assembly and then use the subsequent code. So that's that process there. Let's check in on our job view real quick. And we're actually finished. So it says it's still, I know it's finished because this last box is green. But this is the job graph that was extracted. And if you can see a little bit here, so this node created 184 vertices, and it processed 16.5 gigabytes of data. And so if I jump over, and here's an intermediate aggregate, it only created 3, and it processed 273 kilobytes. And we'll look at another extraction here. So this one created 230 vertices and read in 205 gigabytes of data. So you start to get an idea that we're dealing with a fairly good size of information and size of files. But this is actually finished, and it took 3.2 minutes. Total running time of 3.5 minutes. So I'm going to pay that 100 parallel cost, which was $8.33 a minute, is what we looked at earlier, give or take. I'm going to pay that for 3.5 minutes. Had I run this with only 2 or 3 or 5, I might have paid a lot less, but it might have taken, 4 hours instead, which is an awful lot of more minutes. And so again, you just kind of have to experiment and sort of find that sweet spot. And sometimes just getting the job done is worth some extra money. And so just throw a ton of ad allows at it. So I think that we're just about at the end of the things that I wanted to share with you and show you today. If I showed you it's just a CSV file. The only reason I'm not going to open it up is just a CSV file. But so we actually outputted 2 of them. So both of these files have been created for us. And if I were to go into my storage account, you would see those 2 files now exist there. So unless anyone has any questions, I think that's all that I have to present. So I'll turn it back over to Nikita.
All right. Thank you so much.
You're welcome. Happy to do it.
Great. I will just give a few minutes here, see if anyone has any questions. If you're catching the replay later, then you can still submit a question and we'll receive an email and can have that answered for you via email later. Or if you are like me and just never think of questions on the spot and want to ask something later, just reach out and we'll get the answer for you. So I don't think there's anything. Well, great. Thank you, everyone, for stopping by. And thanks again, Joel, for that information. That's awesome.
You're very welcome. Thanks, everyone, for attending.
Great. We'll hopefully see everyone at our December 6th webinar. Take care.
Thank you.
Thanks.